All right, so we're going to go over the multiple choice questions from the first part of the 1998 AP Calculus AB exam. So in this video, I'm going to try to basically try to not go like super detailed, but not go fast. So I'm going to try to explain each problem um well enough so that you can kind of work through each problem at a good pace. So that way it's like reasonable to see if you can actually go through these problems all in like 55 minutes. So starting off with problem one, we have what's the x coordinate of the point of inflection on the graph of y is 1/3 x cubed plus 5x squared plus 24. So when we're talking about the point of inflection, remember we want to study the second derivative, and we want to see when the second derivative changes from like a positive to a negative, or from a negative to a positive, or think of it graphically as concave down to concave up, or concave up to concave down. So there's different ways to go about this, but the key is, let's start off by finding the second derivative. So we're going to find y prime to be 3 times 1/3 x squared, or just that'll just give us what I'll leave us with x squared plus 10x. The second derivative will then be 2x plus 10. Then we solve for where the second derivative is undefined or where it's equal to 0. So when y double prime equals 0, that would be then at x equals -5. So we want to see what's going on before -5 and like after -5. So we can pick arbitrary values like -10 and then 0, and want to see the behavior of the second derivative. Now the thing is that like this was the only possible value that would work for this equation. So like we already say that the answer is going to be -5 because there's no other possible one that we could have. It doesn't say like none, no inflection points. Well, let me just go through it as if we don't have multiple choice. So if, for example, we want to see what y double prime of -10 is and what y double prime of 0 is. So y double prime of -10 would then be -20 plus 10. So that would be -10. So then it would be negative. The graph would be concave down on this side. Not very good. On this side, then we plug in 0 into this equation, and y double prime of 0 would just be +10. So it's going to be positive. And so you see it's going from concave down to concave up. So yeah, this would be an inflection point. So our answer would be D. All right, problem 2. I think I have some room to fit in to draw it on here. So let's go with that. We're given this piecewise linear function, and we're looking at an interval from -1 to 4, and we want to find what's the integral of f of x from -1 to 4. So essentially, we just want to look at the area trapped by the curve. So we have a triangle here, a rectangle here, another triangle, and a square. So this will give us an area of +1. This is an area of +2, an area of +1 again. Now this is going to be -1/2 because it's below the x-axis, and likewise this is going to be -1. So we just add 1 plus 2 plus 1 minus 1/2 minus 1, and that's going to leave us with 2.5. And so the answer is B. All right, going on to problem 3. We have the integral from 1 to 2 of 1 over x squared dx. This is just going to be the same integral as x to the -2 dx. So using, anti-differentiation or integration, we're going to get x to the -1 over -1. and we're going to integrate from 1 to 2. So then we're just basically, let's rewrite this actually as 1 over negative x from 1 to 2. Plug in 2 into here, we're going to get negative 1/2. I don't know why I just wrote it that way, but negative 1/2 minus negative 1. So negative 1/2 plus 1. So then we'll just get positive 1/2. And so the answer will be C. All right, next. We have if f is continuous for the interval a to b, closed interval, I guess, and it's differentiable in the open interval from a to b, which of the following could be false? Okay, so this we can kind of see it's going to be dealing with the mean value theorem. So the first one is saying f prime of c equals f of b minus f of a over b minus a. This is just saying that at some point, like, I mean, let's draw a visual actually. So let's call this A, let's call this B. And if f is going to be running through A and B, then some point C in the middle between A and B, it's basically saying that the slope of C, there's some point in the middle of A and B, such that if you draw a slope through AB, like a line like that, there's going to be another value that's going to have a parallel tangent line. And, you know, we could, like, coincidentally, it's going to be something like this. So review the mean value theorem in case you need a little, like, extra work with this. But A is going to hold. That's what the mean value theorem says. Now, f prime of c equals 0 for some c such that c is between A and B. So this doesn't have to be true because this doesn't have to be like this, like there doesn't have to be a horizontal tangent line. That's only going to be, this only holds if f of A is equal to f of B. Because that means A and B, that means both of these points are like, you know, the same y value. If you had something like this, then yeah, you're going to have another line between those that's going to have a horizontal slope. This is Rolle's theorem they're talking about. So B's, right away we know B is then going to be false. Problem 5, the integral from 0 to x of sine of t dt. So this is basically going to have to do with the second fundamental theorem of calculus, where we just take the function whose derivative is the sine of t, which is going to be negative cosine of t. But in this case, we're going to plug in, we're going to evaluate it 0 and x, just like we do with the a definite integral. So we're going to have negative cosine of x minus negative cosine of 0, which is just going to be negative cosine of x plus cosine of 0 is 1, so plus 1. And so the answer will just, yeah, E, it'll just be E. It's just rewritten in a different order. Problem 6, if x squared plus xy equals 10, then when x equals 2, dy dx equals. Okay, so here, let me actually work it out on paper. So we're going to use implicit differentiation So let's solve for dy dx here. So differentiating that, we're going to get 2x plus, here we're going to use the product rule. So 1y plus x dy dx is equal to 0. Solving this for dy dx, we're going to get dy dx negative 2x minus y divided by x. This is going to be dy dx, but we want to evaluate this when x is 2. But since we have a y value in here, we need to figure out what the y value is when x is 2. So for that, we just use this equation. We just use our original equation to solve for y, because then we get 4 plus 2y equals 10. 2y equals 6, and then y will just be 3. So we're going to plug both of these into here. So we're going to get negative 2 times 2 minus 3 over 2. The negative 7 halves will be our answer. And so that'll be A. All right, problem 7. The integral from 1 to e of x squared minus 1 over x dx. So we're going to break this up as x squared over x minus 1 over x dx. This is going to be the same as x minus 1 over x dx. Integrating this will be much easier, and we'll then get x squared over 2 minus the natural log of x with the absolute value of the natural log of x. Evaluating from 1 to e. So let me work this up over here. Plug in e first. We're going to get e squared over 2 minus the natural log of e. The natural log of e is just going to be 1, because e raised to the 1 is going to be e. Then minus, plugging 1 into x, we'll get 1/2 minus the natural log of 1, which is just 0. And then so we get e squared over 2 minus 3/2. And so then our answer will be E. All right, problem 8. Let me just work this through, because this will be a little better to kind of see it without answers. So if f and g are differentiable functions with the following properties, g of x is always positive, and f of 0 is 1. If h of x equals f of x times g of x, and h prime of x equals f of x times g prime of x, then f of x is. Okay, so let's, in general, h prime of x, we would have to use the product rule. So this would be f prime of x times g of x plus f of x times g prime of x. But apparently, like, this is just going to be equal to f of x times g prime of x. So it's like this essentially is going to be 0. So what that means is that f prime of x equals 0. And for f prime of x to be 0, that means then that f of x is going to be a constant. F of x is just going to equal some number, because the derivative of a constant is just going to be 0. So then looking at a constant, the only constant here would be e, which is 1, and then so that's going to be our answer. All right, moving on. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day? So we essentially just want to find like this area, the area underneath the curve and between the horizontal axis to this area. So each of these squares would be 6 times 100. So each of these squares would be 600. So 600, 600, 600, 600. We probably have one more square up here, another 600. 1, 2, 3, 4, 5. So maybe around 3. Okay, yeah. So then this should be pretty clear, or the answers aren't too close together. So it's going to be 3,000. Because we have about 5 of those rectangles. I think I was saying squares, but rectangles, whatever. Number 10, what's the instantaneous rate of change at x equals 2 of the function f given by this? So we really just got to find the derivative of this and then plug in 2, because that's what instantaneous rate of change is. So we're going to use the quotient rule, which is going to give us the denominator function, or the denominator will be squared. On top, we're going to take the bottom function multiplied by the derivative of the top function, so multiplied by 2x, minus the top function multiplied by the derivative of the bottom. So remember, like if you have like f g, the derivative of f over g of x is going to be the bottom squared. On top, you're going to have g times f prime minus f times g prime. In case you make sure you remember this rule. So then we just have to evaluate this and plug in 2. We could probably plug in 2 first. It'll probably be easier. So plugging in 2, we will get 2 minus 1. We'll get 1 times 4 minus 4 minus 2. 2 over 2 minus 1 squared, so 1. So 4 minus 2, we'll just get 2, right? I didn't make a mistake. So our answer will be D. That's pretty easy. All right, 11. If f is a linear function and a is and 0 is less than a and a is less than b, then the integral from 0 to a, or the integral from a to b of f double prime of x dx is. Okay, so for this one, it's basically just a conceptual question, because if we're saying that f is a linear function, then we are going to have a straight line. So let's say, for example, f maybe could look like this. But we're integrating not f. If we were to integrate f from a to b, that would be like this. That would be something like this. But we're integrating the second derivative from a to b. So like let's say the first derivative would be it would be a horizontal line. I don't know whether it's gonna be positive or negative, but the first derivative would be something like that. Because you're gonna integrate basically the area from a to b of a horizontal line, because the derivative of a linear equation is a constant. But if you're going to integrate the derivative of the derivative, there is no slope. So there's not going to be any area of the second derivative. So the answer is going to be A, we'll just have 0. All right, problem 12, we have if the function f of x is equal to this piecewise equation, where it's going to be ln of x, or the natural log of x, for values of x between 0 and less than or equal to 2. But it's going to be then also equal to x squared. Well, not also, but it's going to be equal to x squared times the natural log of 2 when x is greater than 2, but less than or equal to 4. So we want to find the limit as x approaches 2 of f of x. Now, this is actually more of like a continuity question than necessarily calculus. But we want to see essentially if the limit as x approaches 2 from the negative side of f of x, we want to see if that's equal to the limit as x approaches 2 from the positive side of f of x. So we want to see if those are equal. So approaching 2 from the negative side would mean that we're going to use natural log of x, because that's going to be for values less than 2. So we plug in 2 into that, and that would just give us the natural log of 2. And let's see if that's equal to the other side. So we would then plug in 2 into this equation. 2 squared times the natural log of 2, or 4 times the natural log of 2. And that's obviously not equal to each other. So the answer is going to be E, non-existent. Okay, well, excuse me. I'm going to take a break right here. Give me some feedback. Let me know if this is helping you or if there's something I can do to improve. I'm going to also be posting review videos of the units coming soon, so keep an eye out for that, because I'm going to try to summarize everything in the entire AP course, so that it's really convenient for you guys to study right before the exam. All right, so I'll see you guys in the next video.